Section 2.4 talks about average rate of change of a function. We have net change. Net change is simply taking, let's say we have y equal f of x. If we're looking from x equal a to x equal b, the net change will simply be y2 minus y1. Nothing to it. The average rate of change would be pretty much the slope, y2 minus y1 over x2 minus x1. Fairly simple. If I have a graph, and I'm looking at y equal f of x, if I run this from x equal a to x equal b, the slope of this line would be the average rate of change. But if I want to find the net change, that's simply y2 minus y1. That's the net. So I have one example that has a lot of parts. Find the net change and the average rate of change. Well, net change is simply, let's get, if x equal 2, put 2 in there. That will be 2 plus 1, which is 3. And if x equal, I meant for that to be a 4. If x equal 4, y would be half of 4 is 2 plus 2. That is also a 4. So the net would simply be 4 minus 3, which is 1. The average rate of change would be pretty much 4 minus 3, which is the net, divided by 4 minus 2. That would be simply 1/2. Very simple to do with numbers. Well, the indication is that we're going to be dealing with non-numbers soon. If I want to deal with the net here, well, I need to figure out what these points are. If x equal negative 3, 9 minus 2 is 7. And if x equals a 1, 1 minus 2 is a negative 1. The net is always end minus beginning, negative 8. And if I want to find the average rate of change, that is the negative 8, y2 minus y1 over x2 minus x1. That would be a negative 8 over 4. That would be a negative 2. Graphically, you could glance at this. You don't have to do this graphically. Oops. Didn't register. Here we go. If I look at x squared minus 2, if I look at x equal negative 3, I am up here at negative 3 at 7 and 1 negative 1. So you notice the slope of the line is negative, and the net is always end minus beginning. You're coming down, that's why it's negative. As for f, well, again, from 1, if x equal 1, y equals 2 minus 3, which is negative 1. Now, I know you're not used to 1 plus h. If x equal 1 plus h, y would equal 2 minus 3 into 1 plus h squared. That's 2 minus 3 into 1 plus 2h plus h squared. 2 minus 3 minus 6h minus 3h squared. That will be negative 1 minus 6h minus 3h squared. Now, I know that's not ideal, but this is where we're heading. So if I want to find the net, that would be y2 minus y1. That will simply be negative 6h minus 3h squared. That's the net. If I want to find the average, no need to reinvent the wheel. I already did y2 minus y1. That's negative 6h minus 3h squared over x2 minus x1. Those cancel out. If I factor an h out of the top, those cancel out. And my average would be negative 6 minus 3h. That's an expression because they didn't give us a value. They tell us where h is, plug h and you'll get the answer. Same deal here. If x equals 0, I'll get 2/3. And if x equal h, I'll get 2 over h plus 3. Again, unpleasant, something you gotta get used to. If I want to find the net, that's simply y2 minus y1, and I'll clean that up, all over 3 into 3 plus h, or h plus 3. That will be, multiply this by 3 top and bottom, that's a 6, minus, multiply this by h plus 3 top and bottom, that would be 6 minus 2h minus 6 over 3 into 3 plus h. That would be a negative 2h divided by 3 into 3 plus h. Again, this is not all a waste of time, because when I say find the average rate of change, you will say, well, that is y2 minus y1. I already found it. Oh, I forgot to put the h there. So that is y2 minus y1, negative 2h over 3 into 3 plus h over x2 minus x1, h minus 0. That is negative 2h over 3 into 3 plus h. And instead of dividing by h over 1, I'm going to multiply by the reciprocal. And the h's cancel out. And the average rate of change would be a negative 2 over 3 into 3 plus h. Here, if I let x equal a, y would be radical a. If I let h equal a plus x, t equal h plus a plus h, that would be the square root of a plus h. To find the net, again, that's really the busy work. That's y2 minus y1. Done deal. If I say find the average, now the key is that denominator is going to cancel out the h. So I take the net over a plus h minus, anytime you do from a to a plus h, you should know that the h in the denominator is going to cancel out. I didn't subtract them, my mistake. Minus a, right? Because it's y2 minus y1. The a's cancel out. Now I'm stuck. If I do this correctly, that h in the denominator is going to cancel out every time. Every time I run from a variable to a variable, same variable plus h. So the only way to really get rid of that h is to multiply by the conjugate. If you recall, conjugate is the same exact two terms, except you switch the sign from a positive to a negative. The top is guaranteed to be the first squared minus the second squared. The a's cancel out, and you'll notice the h's will cancel out as well. And I'm left with 1 over the square root of a plus h plus square root of a. By the way, this average rate of change has a name. They call it difference quotient. That's something that you do in calculus for almost 2 chapters. Same deal here. If I look for the net, it's going to be a lot of work, but that's the majority of the problem. the net is going to be, well, let's see. If I put in x equal a, well, I'll get a cubed plus 1. That's simple. If I let x equal a plus h, I'm going to get a plus h cubed plus 1. That's going to be a cubed plus 3a squared h plus 3ah squared plus h cubed plus 1. That mess is right there. When I say net, you take y2 minus y1. I'm sorry, the other y1. y1. That would be a cubed plus 3a squared h plus 3ah squared plus h cubed plus 1 minus a cubed minus 1. The a cubes cancel out and the positive and the negative one cancel out. So I got the net to be 3a squared h plus 3ah squared plus h cubed. Done. And now if I say, what's the average rate of change? You'll say y2 minus y1. Instead of doing the busy work, I already have it. It's right there. Over x2 minus x1. Those cancel out. I'll factor an h out of the top because I am aware that the h's will cancel out every time. Which h? This h. And once you cancel that, pretty much you're done. And that's pretty much it for this section. I am going to derive the formula for you now that you saw it. If you happen to see a graph, instead of b, if I was to make that a plus h, wouldn't that be a plus h f of a plus h? And this point will be a f of a. So if I say, what is the slope of the line? What did you say the slope of the line? y2 minus y1 over x2 minus x1. Those cancel out. So you are guaranteed every time you deal with a number and a number plus h to cancel that h in the denominator every single time, no exception.